Dear students, today we shall discuss another form of the straight line which is called as the two-point form. So in two-point form we have to find the equation of this straight line which passes through two given fixed points. Like we have to find the equation of the line which passes through the point say P of x1 y1 and Q of x2 y2. Now let's suppose this line L1 or line L, this L1 we are line which passes through these 2 points, that is P of x1 y1 and Q of x2 y2. Let R of xy be any arbitrary point on this line, that is this R is any point on this line. Then clearly this P, Q and R are collinear because they lies on the same line, which implies that slope of PR, this PR equals to slope of PQ because both are parallel, hence their slopes are equal. Now using the slope of the line through 2 points, which is here coordinates of R are xy, coordinates of P are x1 y1, which implies that slope of this PR is y minus y1 upon x minus x1. Similarly this PQ coordinates are x1 y1 and x2 y2, which implies that slope of PQ equals to y2 minus y1 upon x2 minus x1. Or by cross multiplication we simply get y1 minus y minus y1 equals to y2 minus y1 upon x2 minus x1 into x minus x1. So this is the required equation of a straight line which passes through two given fixed points, that is x1 y1 and x2 y2. Like if we consider an example, find the equation of line which passes through point P of 2 5 Q of 1 3. Here P of x1 y1 is P of 2 5, which implies that x1 is 2, y1 is 5. Similarly Q of x2 y2 is Q of 1 3, which implies that by substituting in given equation, because here we use this 2 point form because 2 points are given, that is y minus y1 equals to y2 minus y1 upon x2 minus x1 into x minus x1. Here y1 is 5, x1 is 2, y2 is 3, x2 is 1. So when we substitute we simply get 2x minus y equals to minus 1 or 2x minus 1 plus 1 equals to 0. So this is the required equation of the straight line which passes through the point P of 2 5 and Q of 1 3. Now another form of the straight line is slope-intercept form. So in this form we have to find the equation of the line whose slope and intercept on y-axis or intercept on any axis is given. Now here this line L with slope m, and it makes an intercept C on y-axis, which implies it cuts y-axis at a distance of c units from origin. So when it cuts c units from the origin, which implies that the coordinates of q where this line intersects the y-axis are 0 c, because any point on y-axis is of the form of 0 c. Also its slope is m. Let p of xy be arbitrary point on this line. So this means that we have to here the slope of this line which passes through q of 0 c and p of xy is given by y minus c upon x minus 0. But the slope of this line is m, which implies that m equals to y minus c upon x minus 0, or by cross multiplication y minus c equals to mx or y equals to mx plus c. So this is the required equation of the line whose slope is m and it makes an intercept C on y-axis, but this intercept is on the positive side of y-axis. If it makes an intercept or if it cuts the y-axis at a distance of c units from the origin but from the negative side, which implies that here we have to simply replace c by minus c, hence y equals to mx minus c is the required equation of the line which cuts an intercept c on the negative y-axis and having slope m. Now similarly if we consider intercept on x-axis, which implies that here this c lies on x-axis at a distance of c units from this origin, but on the positive side. Then coordinates of this q are c0. Let p of x y be arbitrarily point, which implies that slope of this line pq equals to y minus 0 upon x minus c, but the slope is m because it is given, which implies that y equals to m into x minus c. So y equals to m times x minus c is the required equation of the line whose slope is m and making an intercept c on positive x-axis. If it makes an intercept c on negative x-axis, then we have to replace simply c by minus c, that is y equals to m into x plus c, by substituting c equals to minus c in equation second. Hence it is also the slope intercept form. This is also slope intercept form. So we have four types of slope intercept form. In slope intercept form, simply intercept as well as the slope is given. Like if we consider an example, find the equation of line which makes an intercept 5 on y-axis with slope equals to 2. Here c equals to 5 because here c is positive, that is 5, m equals to 2. Substituting in y equals to mx plus c, we simply get y equals to 2x plus 5, which is required equation of this line having slope 2 and making an intercept 5 on y-axis. Now another form of the straight line is intercept form. Intercept form means that form in which two intercepts are given, that is line makes an line makes two intercepts on x-axis, one on x-axis, second one on y-axis. Let's assume that the b be the intercept on y-axis and a be the intercept on this x-axis, which implies that the point where this line cuts the x-axis or intersects the x-axis have coordinates equals to a0, while as on y-axis coordinates are 0 b. So this means that we have to find the line equation of line which passes through 2 points, one a0, second one 0 b. So using 2-point form, which is y minus y1 equals to y2 minus y1 upon x2 minus x1 into x minus x1, we get y minus b equals to 0 minus b upon a minus 0 into x minus 0, or by cross multiplication we simply get bx plus ay equals to ab. So when we dividing by ab, because a and b both are non-negative, this non-zero, so we can divide, which implies that x by a plus y by b equals to 1. Here a is intercept on x-axis, b is intercept on y-axis. So simply the denominator of x gives us the intercept on x-axis, while as denominator on this denominator of y gives intercept on y-axis. X by a plus y by b equals to 1 is required equation. Here both intercepts are positive. If both are negative or one of them is negative, so we have to simply replace their direction by negative. So this is the required intercept form. So thank you.